Hey guys, today we're going to cover direct, inverse, and joint variation. And little did you know, you probably don't remember, a long time ago, we skipped chapter 2.5, which was direct variation. And the reason I skipped that is because we're going to cover direct variation, inverse, and joint variation in 8.1, and it makes more sense to save the time and cover it all at once because I think you guys are going to handle what we're covering today pretty quickly. So let's go ahead and go to the next slide. Okay, so here we go. This is a simple equation. You might notice it as y equals mx plus b, there we go. Where if I were to put something in for my dependent variable, x, my y is going to change. So as x varies, so does y. If x gets larger, this side of the equation gets larger, so does the other side of the equation. And we have inverse variation when the a value is actually over the x. And this is new to us. As x gets larger, it is now the denominator, and the denominator then is getting larger. That makes this smaller. Y is also getting smaller. So in a direct variation equation, as my independent variable is getting larger, so is my dependent variable because it depends on what's happening with x. As an inverse equation, this relationship is as x gets larger, y is getting smaller, so they are inversely proportional to each other. We're going to explore this a lot today. One concept you need to recognize is that the y-intercept is always 0. These two equations start at the point 0, 0, and from there it's either linear or it does something else. We'll explore this more in 8.2, but for now, remember that both of these variations, they start at the intercept of 0. Okay, so a little terminology we need to know is the a value in both of these equations is called the constant of variation. And I will refer to this quite a bit. But this a value, it is the number that creates the variation, and it is the magnitude or the scale of the variation in both of these equations. Both direct and inverse variations have a constant of variation. At times it could be just 1. At other times it can be a positive or a negative number. Any integer is acceptable. All right, so please make sure you have both of these copied down in your notes, and I am going to move to the next slide. Thank you. All right, so we're looking at a couple of, we have 6 equations here, and we're going to work these and decide whether they're direct, inverse variations, or if they are neither. For this first one, I know that I need to solve it for y, so it's a y equals equation. Y is our dependent variable. So I'm going to go ahead and divide both sides of this first equation by 3, and then what you'll notice is that y is equal to 2/3 x, and that is a direct variation where the a value is 2/3. So you can write that as a linear equation I'm going to do it up here because I have room. Y is equal to my slope of 2/3 and here, let's erase that. Let's make it red. 2/3 x plus, and we'll use purple because that's what I used earlier, 0. So you will notice the important concept here is the x is a whole number. It is not in the denominator. So this now is a direct variation, not an inverse. So let's move on to the next one and see what we got. I'm going to add 4 to both sides, solving for y. Y is equal to x plus 4. In front of this x is a 1. This is not a direct variation, even though it looks like it. There is a plus 4 here. It does not go through the origin, so we would say it is neither. Alright, moving on to the next one. I need to solve for y, so I'm going to divide by 4x on both sides. I'm going to move up top so I have some room here. Y is equal to 8 over 4x, which is the same as 2 over x. So y is equal to 2 over x plus 0. Remember, we have an intercept out there. That's our y-intercept. This is an inverse variation, and the constant of variation in this case is 2. All right. Earlier we saw we had the equation y equals a over x. That's the situation we're in. This is an inverse variation. All right, moving on. Number 4. I'm going to do some algebra here. I want to solve this for y. My first math move will be to subtract 12 from both sides. I'm going to, in the same move, I'm going to divide by negative 3x. All of this by negative 3x, and then I'm going to clean this up. So I have y is equal to 11, and it's negative, over negative 3x, which is equal to a positive 11 over 3x. So this is an inverse variation. My constant of variation is 11/3. I do have an intercept of 0, so it is a direct or inverse variation. And remember, 11/3 is just a number. I could write it in the numerator as a decimal, so this is an inverse variation. I'm gonna erase some stuff. Hang tight. Here we go. Next one. Solve for y. My first math move. Let me write all this out. I think I'm going to pull this negative 2y over here, and it is equal to negative 6x. And then I'm going to divide both sides by negative 2. Y is equal to 3x. There is a positive 0 out there. So this is a direct variation. As x gets larger, so does y. It varies directly. Let's try the next one, see how it goes. I'm solving for y. I'm going to add 2x to both sides. So now I have 1/2 y equal to 2x. Now to eliminate the 1/2, I'm going to multiply both sides by 2. And that leaves me with y is equal to 4x. Plus, there is a intercept, the additive identity. We generally don't write it. This is a direct variation. My constant of variation is 4. Looking back, constant of variation, constant of variation. Where else are we at? Yep. How about over there? Constant of variation. Yeah. As we move along, we're going to be solving for that constant. All right, so we have 2 examples here, and I think this is when it gets kind of sticky, but I don't know that it's too terrible. One thing we want to know is what varies. That's the terminology we're going to be looking for. And it says that the variables x and y vary inversely. So if it's varying inversely, I should have this equation. Y is equal to constant of variation over x. And I generally never write this, but I want you to realize that it has to be plus 0. It's going to go through the origin. Y is equal to 0 if it is a variation, either direct or inverse. So let's write this out. It says that y is 7 when, and it's inverse when x is 4. So we're going to solve for the constant of variation. We're going to solve for the a value. So to do so, I'm going to multiply both sides by 4. And I'm going to get 28 is equal to a. So now my constant of variation is 28. It says here, write an equation that relates x and y, and then find y when x is equal to -2. So I'm going to write that equation. I know that, I'm going to erase this. I know that my constant of variation is 28, so I'm going to write the general equation for this. It is y is equal to 28 over x. So it says find y when x is equal to -2. I'm going to erase some. Are you ready for it? Here it goes. All right. So when find y when x is equal to -2, well, y is equal to 28 divided by -2. Y is equal to -14. So this is the equation that shows the relationship between x and y, and this is the value of y when x is equal to -2. All right, why don't you try the next one on your own? I believe the equations are going to work the same way. There's nothing new here, and I'll post the answers in a moment. Alright, so I worked the problem. Hopefully you paused it long enough and you can work it. When y is 4 and x is 2, I know that it varies inversely. So to get rid of the denominator, I'm going to multiply both sides by 2, and then a will become equal to 8. So I can rewrite the equation. This is the equation that relates x and y. Y is equal to 8 over x. And when x is equal to 3, plug 3 in, y is equal to 8 thirds. Alright? If you have questions, ask your neighbor. Great time to pause it. If you guys are struggling, we can work on this later. Here we go. Next slide. So if I told you that these are potentially an inverse relationship between these xy points on this table, we could verify this by checking for the constant of variation. Alright, so we can check to see, according to this table, it says that it is an inverse variation and we need to verify that it is true. To do so, we're going to set up the equation y is equal to a over x to verify that this is in fact true. Well, my first y value is 5,000, and that is equal to a over my x value. My x value is 2. So I will multiply both sides by, let's make that green, by 2. Multiply both sides by 2. So 10,000 is equal to a. So let's go ahead and check it on the next couple and see. 4,000. So the second one is equal to a divided by 2.5. Multiply both sides by 2.5. And 2 times 4,000 is 8,000, and half of that is definitely 10,000. So 10,000 is equal to A. And I think you can go through and verify this. The 3,333 might cause a problem. I think we're going to be at a 9. That'll be 9,999. And everything else is going to work out great. This one really should be with a 0.33 repeating. Other than that, this is an inverse variation. I think we'll be okay. We can just say that, let's ignore this last point here. This one right here creates a small problem. But constant of variation is 10,000. That is our A. So we can verify, or we can find our constant of variation. That is the important concept in this. 10,000. There we go. All right. So joint variation. We learned direct and inverse, and now we have joint variation, and it occurs when a quantity varies directly with a product of two or more other quantities. In the equation below, what equation do you have there? Let's see what we have. Let's write this in. We would say that z varies directly with x and y. Oop. All right, so we actually have two components inside the equation that z itself varies with. So if x goes up, z goes up. If y goes up, z goes up. Now if x and y go in opposite directions, whichever one goes has the larger magnitude, z will go up or down. This constant of variation just regulates how much z changes relative, or the relationship, to x and y. In this case, we would say that z varies jointly with x and y. Now, let's try another one. We could actually have something like p, and we could say that p varies jointly. We need a constant of variation, this a value, and it can vary jointly with q, r, and s. So we would say that z varies jointly with q, r, and s. Ooh, not an s, maybe. Come on. All right. Joint variations. Let's see what you have on your notes next. I'm going to kind of go off script a little bit and play this out. So, quick erase. This is a good time to just pay attention. Wish I had a bigger eraser. That'd be great. All right. So I could tell you that z varies jointly and I know I need a constant of variation. And if it varies jointly with, say, x, but inversely with y, I can write it that way. So you'll notice that the joint variation is this component here. Z equals a times x. But the inverse variation is z equals a divided by x. Now, this is one equation, and if x is getting larger, this whole equation is getting larger. And if y is getting larger, this whole equation is getting smaller. As the denominator gets bigger, the equation is going to get smaller. It is possible to have a joint variation where z is impacted either directly by x or inversely by y. So as we go through the homework set, I believe you're going to see some where they're going to say z varies directly by some number and inversely by some number. Don't forget there's always some constant of variation built into these equations. All right, let's see. I'm going to pause it now, and we're going to work these next 5 problems and see what we come up with. We are just going to write the y equals or z equals. Oh, there's an x equals in there too. So we're going to write the variation equations, and I will post the answers, and then you will start the homework set when we're done with this. If you have questions, ask your neighbors. All right, never mind. I lied. Z varies jointly with x and y. So let's go ahead and figure out what this constant of variation is. I know z varies jointly with x and y, so here's my x, here's my y. Z is negative 75 when x is 3 and y is negative 5. So let's write that equation. Negative 75 constant of variation. X is 3 and y is negative 5. Oh, there's Russell making a noise. All right. All right. Constant of variation is 5. And it says, what do we have for z when x is 2 and y is 6? So we can do that real quick. Z, constant of variation, is 5. And my x is 2. And y is 6. 30 and 2, we have 60, so z is equal to 60. And the equation, just so you know, is y is equal to constant of variation 5. Oops. Beautiful. All right. That's what you'll present, and that's what you present. Those are the two answers. All right. Now the next 5 questions are all yours. Talk to your neighbor if you have questions. All right. So finish these problems. On the next slide, actually the remainder of your notes, and there's the answers. Nope, not yet. Pause it. Make sure you guys are good with those 5, and I'll post those, and then we'll start the worksheet in class. Hopefully you'll be able to finish that before the period is done. Thank you. All right, next slide for me, which is the rest of your notes. Y varies inversely.